Okay, so hello student, how are you? Good morning. My name is Arun Sharma and I'm your physics teacher, and I'm here with the question discussion part of laws of motion once again. So if I am audible and visible to you and the screen is also visible to you, just write it in the chat box or make a response for that. Okay, so that we can start the class. Just write it in the chat box. Hello Gaurav. Hello Lakshmi, how are you? Hello JNV Bhavnagar, how are you? If I'm audible and visible to you and the screen is also visible to you, then please write it in the chat box, okay? So that we can start the lecture. Okay, screen is visible. Am I audible and visible? Just give write yes if I am. Okay. Okay. Then thank you guys for the response. Now we will move on to our lecture. Okay. Let me just hide this for the better clarification of you. Okay, so here with the laws of motion question discussion, there are some conceptual question today that I am going to discuss with you guys. Okay, and these questions are really very important for you. Okay, so the very first question is this: draw the free body diagram of the following system. Okay, so I am giving you the around 1 minute to solve this question, and for me, you solve part B or whatever you want. Okay, you can solve part A, and I'm giving you 30 seconds for that. Just find the tension. Just draw the free body diagram and find the tension in the row. Okay, if you are able to find this, then please write it in the chat box. Otherwise, I will move on to solving this question. Okay, so here we have two blocks. Firstly, we will discuss part number A. Okay, so solution of part. Okay, now you can see here there are two blocks in this system. One is this, and second one is this, and this is the string. This string is massless, okay, and inextensible. Now, what do you mean by this massless term? Massless होने से string का क्या मतलब है कि the weight of the string will not play any role. Okay, because if the string has some mass, it will also feel a force by the earth, that is the gravitational force or its weight actually. So massless string means the mass of the string will not play any role in this. Okay, and what do you mean by inextensible? Inextensible means like this is the pen, I cannot extend it. Okay, so if the length of the string is constant, then it is termed as the inextensible string. Okay, because if the length can increase, the whole scenario will change. Got it? The tension would be changed, and the system would having more variable forces than the constant. Okay, so here, yeah. So for this, I'm going to draw the FBD of this system. This is M1, this is M2, Okay, so the tension developed in this I will consider at T1, and the tension developed in this I will consider at T2. Or we should uh, yeah, we should assume this tension as T1 because M1 say, and this is as T2, and this is our block M2. Got it? Okay, let me move on to the next slide. So this is the system that we have with M1 block, and this is M2. Got it? The tension here is T1 and the tension here is T2. Now for M2 block, if we try to draw the FBD, what is the FBD? FBD is the free body diagram. Okay. So what we will do, we will draw M2 over here. So what kind of force is acting on the M2? It is the gravitational force M2G directly downward passing through its center of mass, and the tension T1. Okay, since this system is in equilibrium, so this T1 is equals to M2G. Simply, the forces will be equal. So we can write here from this equation T1 is equals to, oh, again I have considered T1 and it as T2. It is T1 and it is T2. So this will be T2. Here it is also T2. T2 is equals to M2G. This is the equation 1 we have for this. Now FBD of M1 block. Okay. So this is, we have M1 over here. Okay. Now what kind of force is acting on the M1? Tell me. One is the gravitational force. One is the gravitational force acting just directly downward, which is M1G. Now there is a T2 in this, which is equal and opposite in nature. So it will also have a force T2. Okay. Because this string having T2 in both the direction. ये M1 ब्लॉक नीचे खींचने की कोशिश कर रहा होगा. M1 is trying to pulling it downward. So string apply the force upward in upward direction on the block M2. So that is why we have shown it here in the upward direction. Okay. अब M1 ब्लॉक के साथ क्या है कि स्ट्रिंग नीचे खींच रही होगी. ओके, स्ट्रिंग नीचे खींच रही होगी. So there is a force of tension T2 developed in this string. So that is T2 over here. Got it? In the downward direction. So this is the force M1 applied by the string. Okay. Okay. And here we have T1. This T1 is also clear to you. This M1 is pulling downward the string. ठीक है, नीचे खींच रहा है, तो वो उस पे ऊपर की तरफ रिएक्शन लगा रही है. दैट इज T1. Okay. And this T2 and this T2 is the equal and opposite forces, like Newton's third law. Okay. So if I try to equate these forces, what is the value? T1 is equals to T2 plus M1G. What is the value of T2 we have? It is M2G plus M1G. So we have T1 here is M1 plus M2 into G. So this is the, finally we have T1 and this is the T2. Okay. Suppose if in this question T2 is not asked to you, only the T1 is asked. Okay. So for that you don't need to draw the FBD for the M2 block and then FBD for M1 block. No. what you can do, you can just, this is the system that you have, this is the block M1, this is the block M2. Okay, so what will you do? You will consider this M1 and M2 as a system. Okay, so this M1 and M2 now will behave as a single block having mass M1 plus M2. Okay, so for this system we have an FBD like this is the tension T1 in the upper portion, and this is the block of M1 plus M2 mass, which is applying a M1 plus M2 gravitational force. Okay, then we will say that T1 is equals to nothing but M1 plus M2 into G. So look how simply we can find it by the applying the concept of system. Okay, so this is the tension we have. Got it? Okay. Now again we have one question left over here. इसे ये सबको समझ में आया? Is there any problem with this question for you? अगर सबको समझ में आया तो then no worries. Please do write in the chat box if you got it. Okay. Meanwhile, I'm solving the next question for you. Have you got this? Yeah. If you are clear with this question, just write it in the chat box. Okay. Now the next part of this question. Okay. ये सबने note कर लिया? Everyone note it down so that I can solve this question over here. Okay. So I hope कि आपने note कर लिया होगा. That is why I'm roughing it down. ठीक है. If anyone has just take the screenshot of it and you will get the answer. ठीक है. Okay, this is the, just a second, it will take a while. Okay, or we can just do something like this. Okay, now for the next question is that this is the block we have of how much mass? It is of m mass. Okay, it is of m mass. Then we have 2m mass, and then we have m mass. So try to draw the FBD for each of the block. The aim of the question is not to find out the tension. Aim of the question is the that you will learn to draw the tension. Okay, draw the tension and FBD of the block. So here we will consider T1, T2 and T3. So for M1, for M mass, M और downward वाला, ठीक है. FBD of it will be FBD of M downward. So what it will be? This is M. Upper part पे tension T1. Downward it has mass into gravitational acceleration. So from here T1 is equals to directly mg. Okay. For FBD of 2m block, what it should be? This is 2m. Okay. This is the tension. सीधा सीधा दिख रहा है T2. This is the mass 2mg. And again, this has the direction upward direction. So for this block, it must be downward. ठीक है. तभी तो टेंशन की कंडीशन सेटिस्फाई होगी, दोनों एंड से टेंशन आ रही है स्ट्रिंग में। ठीक है, तो ये इसे डाउनवर्ड साइड में खींच रही हो ब्लॉक को। कौन? स्ट्रिंग। ये जो स्ट्रिंग अटैच्ड है इसके साथ ये ब्लॉक को डाउनवर्ड डायरेक्शन में खींच रही होगी, दैट इज व्हाई दिस T1 हैज कम इन डाउनवर्ड डायरेक्शन। ओके, so for this T2 is equals to T1 plus 2 mg. T2 is equals to, what is the value of T1? It is mg plus 2 mg. What will we have? We have 3 mg T2. Okay. Now the last part of this question is FBD of FBD of M block, what is upward वाला. ठीक है, so it has, this is M, upward direction में tension T3. Okay, and downward direction में there is a tension of T2. It is going upward, so in this it is going downward T2, and mass of the block it is M. So T3 is nothing but equals to T2 plus mg. What is the value of T2? It is 3 mg plus mg gives you 4 mg. Okay, and if you want to find out the tension T3 directly, you can apply the method of system. You will consider it as system of mass m plus 2m plus m means 4m. So T3 will directly be equals to 4 mg. कैसे? By the concept of system. Got it? Do anyone have any problem in this? Please do write in the chat box, or otherwise we will move on. Okay, please make a response so that I will get ki you are getting the questions. Okay, please make a response. Is this clear to you? Okay, then we will move on to the next question. Next question is this. Okay, Lakshmi, thank you. That's it means that you are paying attention to the class, and it's good for you. Now read this question and try to solve this. You have 1 minute to solve this question. Okay. You have 1 minute to solve this question. So an elevator in a building can carry a maximum of 10 persons with the average mass of each person being 68 kg. Okay. So the mass of elevator itself is 920 kg and it moves with a constant speed of 3 meter per second. Okay. Let me highlight some point over here. It is moving with a constant speed of 3 meter per second. And the mass of elevator is also given 920 kg. Okay. And the frictional force opposing the motion is 6000 Newton. Okay. So we have to calculate the power delivered by the motor. And one important thing also, the elevator is moving up with its full capacity. With its full capacity. Okay. So just solve this question. Solution of this question. Okay. So try to solve this. I have given you 1 minute to solve this question. Okay. At least idea हो आपको कि how to solve, how to proceed in this types of question. ठीक है. So did you get the answer? Any one of you? Lakshmi, Gaurav, any one of you? Or are you trying to solve this question? Just let me know. Okay. So firstly, in every question, what you have to do, firstly, you have to write what is given in the question. Okay. So write the given data. What is given data here? The given data is mass of the elevator is given to you. Mass of elevator. Okay. Which is 920 kg. Okay. Mass of each person is given. Number of person given to you is 10, and mass of each person is about how much? It is 68. Okay. 68 kg. So the total mass is 68 multiplied with 10. So the total mass which is inside the lift is 680 kg. Okay. Now, speed of the elevator is given to you. Speed of elevator is given to you, and how much? It is 3 meter per second. Okay. Sorry. And also the value of frictional force is also given to you. Frictional force. Frictional force is 6,000 Newton. Okay. Now what the concept is, if there is a motor which is running this, which is moving this elevator, so how much work has this motor has to be done? How much work this motor has to be done? Okay, there is a lift, there is some person inside it. Okay, okay. If there is no friction और अब मोटर रन कर रही है, सो मोटर को जस्ट लिफ्ट को अप करना है, फिर लिफ्ट का मास एंड द पर्सन इनसाइड इट will play the role. ठीक है. Only the person which is inside the lift and the mass of the lift will play the role. ठीक है. सिर्फ उसी के अगेंस्ट मोटर को पावर डिलीवर करनी है ताकि वो वेट लिफ्ट अप हो सके. कौन सा वेट? लिफ्ट का वेट प्लस द पर्सन इनसाइड द लिफ्ट, बिकॉज द ग्रेविटेशनल फोर्स एक्टिंग डाउनवर्ड. एंड ऐसा तो नहीं है कि लिफ्ट ऑल्सो मूविंग डाउनवर्ड, बट फॉर दिस मोशन इट इज गोइंग अप. ठीक है. So for upward motion, the forces, all forces are in the negative direction. So we have to put some work so that it can move up. So if there is no friction, what forces are responsible for the work against which the motor has to do work? Only the weight, weight of lift plus the weight inside the lift. Got it? Got it. But now, if the lift is moving upward, there is a frictional force. And if the lift is moving upward, friction always opposes the relative motion. ठीक है. And if the lift is moving upward, so ये ऊपर जाने से इसे मना करेगा. Like this. ये जा रही है तो ये ऊपर जाने से इसे मना करेगा. So it will act downward. So we have three forces here in this case. What is the forces? First is the weight of elevator. Second is the weight inside the elevator. And third is the frictional force. Got it? Got it or not? If you are got it, then write it in the chat box. ठीक है. प्लीज मेक रेस्पॉन्स ताकि आई नो कि एक बारी में समझ में नहीं आता है हमेशा. सो दैट आई विल. ओके. सो ऐसा होता है कि एक बारी में समझ में नहीं आता. सो what the teacher do again, but if you guys not make any response, तो I will understand कि आप बहुत होशियार हो, आपने सब कुछ समझ लिया. And I will move on. Okay. ठीक है. Okay, Lakshmi, you got it. ठीक है. Only Lakshmi is getting it or everyone? ठीक है. So now if I just try to solve this question, this is the elevator that we have and this is the person. ठीक है ना, 10 के बराबर एक ही ले लिया मैंने, ठीक है। एंड दिस लिफ्ट इज मूविंग अपवर्ड, सो फॉर opposite of that the frictional force is down, acting downward, and weight of the lift is also acting downward, and weight of the person is also acting downward. So the total force here is what? Mass of the, sorry, mass of person plus mass of elevator, ठीक है, into g, this is the weight ना, plus the frictional force. So F total here is nothing but weight of the combined system plus frictional force. Weight combined means weight of person plus weight of elevator, ठीक है। Okay, so how many person we have? We have 10%, and each person weighing कितना 68 kg, plus elevator का weight is 920 kg multiplied by g. G is given as 10 na, okay, in the question, plus frictional force is 6000 Newton, ठीक है। So this is 680 plus 920 multiplied with g. Just make the calculation for me. What it is? Take the value of g as 10. Make the calculation for me what it is. I'm doing the calculation for the, okay. You guys can also do this. 680 plus 920 multiplied with 10 plus 6000. So we have, Lakshmi, you got this? What is the total value of this? So it will come as 22,000 Newton. This is the total force against the motor has to work. Okay. Now what is the formula for power? Power is nothing but work done upon time. What is work done? Work done is the force into dot product with displacement divided by time. Okay. So here this F remains the same. This F is acting as the F total, and this d by t is nothing but the speed of the lift, d by t. So this ft dot v. Okay, so what is the power then? Ft is 22,000 multiplied with 3, so it is 66,000. ठीक है क्या? Got it? So option D is the correct option, that is. ठीक है? Anyone has any doubt? So please do write in the chat box. And if you are clear with this question, then also write it in the chat box. Okay. Now the question that we have is this. I'm giving you 1 minute to solve this question. Just try to solve this question. Okay. A spring is compressed between two blocks of mass M1 and M2 placed on a horizontal frictionless surface. I'm highlighting some point as I'm talking. Okay. Along with the reading the question. So let me just change the color of it. Yeah. So this is spring is compressed, okay, and this is placed on a horizontal frictionless surface, as it is visible in the figure also. Okay, when the blocks are released, they have initial velocity v1 and v2. The block travels distance x1 and x2 respectively before coming to rest. Okay, so the ratio of x1 by x2 is. This is a very simple question. फिगर से देखने में ही ऐसा लग रहा होगा कि हाउ टफ दिस क्वेश्चन इज, बट दिस इज अ वेरी हलवा क्वेश्चन, ठीक है। नाउ यू विल सी दैट व्हाट काइंड ऑफ हलवा क्वेश्चन इज दिस, ठीक है। So if you are going to the concept that you are calculating x1 alone, then x2 alone, and then find the ratio of this, it will just give you a headache. Okay. And if you got the answer, then it is not also worth it because you have consumed so much of time. Okay. And the exam that you are aiming is the time limited. So you have to find out some other method. So we are going to find out the method which solve this question in no time. Okay. So again, in the next part, I will solve this question. So this is the spring block system that we have. Okay. Let me just, this is the M1, I must say. Okay. Yeah, this is M1, this is M2. The next is M2. And this is moving with V2. This is also moving with V1. Okay. And this is the spring. Initially, the system is compressed. So the system is compressed, then means the spring is compressed. और compression के बाद spring क्या करना चाह रहा होगा? Spring wants to release itself. ठीक है, इस compression से elongation की तरफ जाना चाह रहा होगा, which means it is applying a force spring force on M1 and M2 both. ठीक है, in this direction. So that is why they are moving in this. ठीक है, V1 इधर मूव कर रहा है, V2 इधर मूव कर रहा है. Now if I talk you about, if I just consider this is M2 and this is M1. If I attach the frame of reference over here, this is y-axis and this is x-axis and this point is the origin. ठीक है, this is origin. So what just happened? This M1 block has moved in the negative x direction and this M2 block has moved in the positive x direction. But if I talk you about the center of mass initially, the center of mass lies between this system initially. Okay. So this is the point where center of mass of the system lies. Okay. Okay. Now this surface is frictionless. There is no friction. Okay. This is frictionless. Just a second. Okay. This surface is frictionless. And if this surface is frictionless, there is no force. Okay. And if I consider this as a system, this whole as a system, so the spring force will become the internal force. Okay. But there is no external force in the system, which means if there is no external force in the system, if there is no external force, which means the momentum of the system is what is conserved. Okay. If momentum of the system is conserved, initially what momentum does the system have? Initially it is at rest, so finally it would also be in rest. Okay. So initial momentum of the system is zero. Okay. which means which means it is nothing but the mass of the system multiplied by the velocity of center of mass equals to also conserved. And initially it has zero, so finally it will also have zero. What is velocity of center of mass? It is nothing but xcom by time. Okay. So which means that xcom is also zero. This zero means the center of mass initially lies at the origin. So finally, after the whatever the process has been done, the spring has elongated itself and the block is moving away from it. But the position of center of mass will not going to change. Okay. And why it is not going to change? Because there is no external force in this system that will cause the change of it. ठीक है। नाउ व्हाट इज द फॉर्मूला फॉर XCOM? XCOM is nothing but M1 x1 plus M2 x2 divided by M1 plus M2, and these x1 and x2 put with the sign. So we have considered this as origin. This side will be the negative side. This side will be the positive side. So M1 into, if x1 is moved in this direction, this is the x1 and this is the x2. Okay. So x1 is moved in the negative direction. So it will consider as minus x1 plus M2 into x2 divided by M1 plus M2 equals to 0. This will go into the 0. Okay. Okay. Then M1 minus M1 x1 plus M2 x2 equals to 0. So M1 x1 equals to M2 x2. Now what do we have to find out? We have to find out the of x1 by x2. So x1 by x2 is equals to nothing but, what is the x1 by x2? It is m2 by m1 according to this relation. Okay, got it? Look how simple is this question with the frame of reference of center of mass, है ना? So option A is the correct option. Have you got this? Have you got this? Just write it in the chat box. We will move on to the next question. Okay. Okay. If you got this, Lakshmi, just reply me. And if you have any doubt, then you can also ask. Okay. So the next question here is, a horizontal force pull two masses M and 2M lying on a frictionless table and connected by a string. Find the tension in the string, and does the answer depends on which mass is and the pull is applied. So that is an interesting question, na? Okay, so let's try to solve this. Solution of this question is here. Look, this is the block we have. This is the another block we have. Okay, and let's say this is M and this is 2M. Okay, and these are connected with a string. Okay, and a horizontal pull force is also applied. Okay, so in case first, what we are considering, in first case, what we are considering, we have applied the pull on this mass, means on M block. This is the F we have. Okay. So what we are going to do, if this force is pulling this here, so there is a tension development in this string. Okay. This string is massless and inextensible, so tension will be distributed uniformly in overall length of the string. Okay. So if I try to draw the FBD of M, what it be? And one thing more, if this system is moving in this direction, so the acceleration is also in this direction. ठीक है, एक्सेलरेशन बदल कौन सकता था? एक्सेलरेशन बदला जा सकता था इस टेंशन की वजह से. ठीक है, if this string is not massless or not uniform, then this tension would have changed, and the tension would have changed means the force applied on 2M block will also change. So that will also change the acceleration of 2M block. But here you can see here that there is no change in the tension. There is a constant force applied on the system, and this surface is also frictionless. So the acceleration of both the block, both the system will be considered as A. Okay. So FBD of M block will be, this is the block M, this is the force F we have, and this is the tension that we have, and this is the acceleration. Got it? Now, now, according to Newton's second law, apply Newton's second law. So न्यूटन सेकंड लॉ कैसे अप्लाई करते हैं? एक्सेलरेशन की डायरेक्शन में जो भी फोर्स है, दैट वुड बी कंसिडर एज पॉजिटिव, अदर फोर्स वुड बी कंसिडर एज नेगेटिव. So this is the F external equals to mass of the system multiplied by the acceleration. What is F external? F external is nothing but F minus T. F is taken as positive, T is taken as negative. Mass is M and this is acceleration. Okay. So this is the equation number 1 that we draw the FBD for 2M. FBD of 2M block. It would be like this is 2M. Okay. This is the only force tension which is pulling it, and it is also accelerating in this direction. So apply Newton's second law, that is F external equals to mass of the block into acceleration. What is F external? It is tension only. And what is mass of the system is 2m into A. Okay. You can just put this value, equation second, in this. Okay. Got it? So what will we get? Then F is equals to nothing but 2ma plus ma. मैं t को इधर लेके चला गया, so it will be positive. So from here what we can say that this F is equals to nothing but 3ma. यहाँ से एक्सेलरेशन की वैल्यू मेरे पास आ गई which is F upon 3m. ठीक है, F upon 3m. What we have to find out? We have to find out the tension. ठीक है, we have to find out the tension in the string. So just put this value of A in the equation number 2. So what do we have in equation number 2? T is equals to 2ma. And what is the value of A? A is nothing but F upon 3m. So 2ma, 2m into F upon 3m. M and M will get cancelled out. So this tension would be nothing but 2F over 3. Okay. This is the case 1 when we have the uh, when we apply the pull force to the smaller mass. Now what just happened if I apply the force on the other block? This is case number 2. So this is the system that we have. This is M. This is 2M. And if I apply the force F in this direction, the acceleration would be in this direction. There is a tension developed. Again, draw the FBD of M. It is M. Sorry. Only the tension would play the role. This is tension T. And the acceleration is this direction, in this direction. So apply Newton's second law. This is F external equals to mass into acceleration. What is the F external here? It is tension equals to mass into acceleration. This is the equation 1 we have. For the FBD of block 2, which is 2m in mass, this is F. Here it is tension and the acceleration in this direction. So F external equals to mass of the system multiplied by acceleration. What is F acceleration? F external. It is F is in the direction of acceleration, so consider positive, minus tension equals to mass of the system is 2m into A. Again, put the value of tension in this. So we have 3ma again because tension is ma. Okay. And from here we can calculate the value of acceleration. What is this? It is F over 3m. You can look, the acceleration is same in both the case as I have told you. Okay. So find the tension. So we have T is equals to m into A. What is m? And A is F over 3m. Okay. M and M got cancel out. So the tension will be F over 3. This tension is less than the previous one because previous one was, if I consider that tension as T1, which be 2F upon 3, which is exactly 2 times of this T. ठीक है, तो इससे प्रैक्टिकल नॉलेज आप लेकर के जा सकते हो कि whenever you got in the physical world, the situation is कि आपके पास दो ब्लॉक है, which one is heavier and one is lower. So try to, and these are connected with a rope. ठीक है, और चेन और समथिंग, तो ट्राई टू पुल द हेवियर ऑब्जेक्ट, ठीक है, इट विल डेवलप द लेस टेंशन. गॉट इट? इफ यू वांट टू पुल इट अर्ली, और इफ यू डू नॉट वांट टू ब्रेक द स्ट्रिंग, ठीक है, देन पुल द, then also pull the two envelope, because it will create the lesser tension in the string, so your string will stand more. Got it? Got it? Now, if you got this, then do write in the chat box, or we will move on to the next question, which is this. Yeah, we have time अभी तो time है हमारे पास. So a uniform row of length L resting on a frictionless surface, horizontal surface, is pulled at once at one end by a force F. ठीक है. Derive an expression for the tension in the rope as a function of position along its length. ठीक है. Here, this is not string. This is the rope. And what is the difference between string and rope? The rope has mass. Got it? ठीक है. And the next part is, if the string is pulled, sorry, if the rope is pulled up. Okay. So we try to solve this by considering the first case. Okay. So we have a uniform rope. This is our rope. Okay. Of length. What is the length of this rope? It is L. Okay. So what we have done, we have applied a force F, one of its end. Okay. सो वी हैव टू डिराइव द टेंशन, जो कि टेंशन डेवलप होगी रोप में, एज द पोजीशन ऑफ फंक्शन. बिकॉज जितना जितना मास आता जाएगा, इफ आई मूव इन दिस डायरेक्शन, दिस इज द रोप दैट आई हैव. लेट मी डू दिस आल्सो. दिस इज द रोप वी हैव. अगर मैं दिस पार्ट ऑफ रोप इज कंसिडर करूं, ओनली दिस पार्ट, दिस हैज लेसर मास, सो टेंशन डेवलप्ड इन दिस will also be less or whatever, but it is not the same. If I consider this portion, then tension will also change. If I consider this, the tension will also change. So means, as I'm changing the position, as I'm moving along the rope, the tension, the value of tension developed has been changed, because there is more mass in this. And tension is nothing but a electromagnetic force. Okay? Yeah, I'm saying this because it is the, when you try to pull the rope, the molecules of that rope do not want to pull, so they applied a contraction force on them in the forms of electromagnetic force. Okay. Electromotive force, I must say, I'm sorry, electromotive force. So they try to pull that. Okay, that is why the tension has been built. Okay. So what we are going to do over here, we will consider a portion of, we will consider this portion of the rope. ठीक है. This portion of the rope we will consider. Okay. Suppose we have considered it as from length x. ठीक है. अभी मैं आपको मास भी निकालना सिखाऊंगा इस तरह के सिस्टम का, हाउ वी कैन फाइंड आउट द मास ऑफ द सिस्टम, like this, in this case, in the case of rope. So this length would be nothing but L minus x. ठीक है. So if I try to draw the FBD, if I try to draw the FBD of part 1, this is our part 1 and this is our part 2. ठीक है. So for FBD of part 1, this is the part 1 that we have. It has a length of x. This is the tension developed in this. ठीक है, in this direction. Because why it is so? If you look at the cross section, this end, just just yeah, okay, this end which is just at the interaction point, ठीक है, अब मैं इसे खींच रहा हूं इस तरफ, सो ये मोलिक्यूल्स इसे इस तरफ खींचना चाह रहे होंगे, ठीक है, ये जो पार्ट है मैं इसे इस तरफ खींच रहा हूँ बाय दिस फोर्स एफ, एंड दिस इज द इंटरेक्शन बाउंड्री। तो इस बाउंड्री के मॉलिक्यूल क्या करे होंगे, नहीं भैया तुम इधर मत जाओ, हमारे पास ही रहो, सो दिस विल अप्लाई अ फोर्स इन दिस डायरेक्शन, so that is why the tension it is in this direction, ठीक है, and there is a force F also that we are applying, ठीक है, so what we can do, and we do not know the mass of this, got it, we do not have any idea about the mass, okay, so what we are going to do, we will just apply the Newton's second law, and obviously the acceleration of all the part will be in the same direction. So F minus T is equals to nothing but mass of this part 1, I'm saying this is M1, and this part has a mass M2, this part has mass M1. So this is M1 into acceleration, ठीक है, like if you try to calculate the mass of this system, now I'm telling you how the mass is to be calculated. We know that, just a second, sorry for the technical glitch. We know that the linear mass density, I hope you all have heard about this, linear mass density. Linear mass density is nothing but the mass per unit length, ठीक है, अब आप ऐसे भी कर सकते हैं, ठीक है, दिस एंटायर लेंथ L has a mass M, ठीक है, got it, and what is the mass of unit length? 1, it is M by L, okay, so if I want to find out the mass of length X, it will be X multiplied by this 1, it is M X divided by L, got it, so F minus T equals to mx over L into A, ठीक है, अब यहाँ पे मुझे सिर्फ और सिर्फ क्या फाइंड आउट करना था, टेंशन एज अ पोजीशन फंक्शन ऑफ x, बट हियर द acceleration is also the remaining part that I have, okay, just give me a second, okay. Okay guys, I'm here, sorry for the gap, okay, so we have this is the equation number 1, got it. So, according to this equation, it is telling us about the relation of force, tension, and the acceleration. Now, we wish to find out the acceleration of whole system. So, what we are going to do, this is the entire rope that we have of length L. Okay? This is the external force only, and this is the acceleration of the system. So, this, if I apply the Newton's second law, it is F is equals to mass of the rod into acceleration. So acceleration is nothing but force upon mass. Okay, so this value you would keep in your mind. Okay, so If I put this acceleration in this equation, what will we get? F minus t is equals to m into x, okay, divided by L multiplied by what is the value of acceleration? F by m. This m and m will got cancel out. Okay. So what do we left with? I'm moving on to the next page. F minus t is equals to, what do we have? Mx over L into acceleration, which is F by m. Then m and m will got cancel out. So we have F minus t equals to what? Equals to xf over L. We have to find out that relation of tension with x. Here F is a constant force, length is also constant. Yeah, we have with the relation. So if I just move the t here and this value here, so what will we have? F minus xf over L. And if I take this f out, so we have this beautiful relation x over L. ठीक है, मीन्स जैसे जैसे x बढ़ेगा, this ratio, what is this ratio? This ratio is always less than 1. ठीक है, and if I increase the value of x, if x increase, if x increases, this x by L, what, ऊपर न्यूमरेटर बढ़ रहा है, नीचे डिनोमिनेटर इज कांस्टेंट, so what is the value? So this will also increase, and if it will increase, this entire system will decrease its value. Means the tension multiply by the force, and this is decreasing, so the tension will be decreasing as if we move along this. Okay, so this is the relation that we have. Now if you have any trouble with this, you can just write it in the chat box, or if you got this, just let me know. I'm revising it for you. We have considered the first part of the system, that is m1 mass. ठीक है, m1 mass हमने कैसे कैलकुलेट किया? Entire length has mass m. ठीक है, one unit length has mass of m by L. So what is the x unit have? It is mx by L. ठीक है, it is the unitary method that I have recalled here. We have calculated the total acceleration of the system. So we would consider entire row. There is an external force F only. This is the A and this is L. So applying Newton's second law, F is equals to ma. We have find out the value of acceleration, which is F by m. Okay. We have drawn the FPD of first part. There is only part one is there. There is only part one is there, means x length. We have applied a force F, and there is a developed tension in this direction T. So we have both the force in opposite direction. F minus T is equals to m1a is the Newton's second law. What is the mass m1? We have also calculated it, mx by L. We have put the value. We have also calculated the value of acceleration, which is F by m. We put this value in this expression, in this, and then here we are. Here we are with the relation that F is equals to T is equals to F into 1 minus X by L. So if you have any kind of doubt in this question, you can just ask in the chat box. Okay. Okay. So I think the time is up. So we will discuss the next part in the next question discussion session. Okay. I hope you guys have enjoyed it. Okay. मैंने तो बहुत enjoy किया. I hope you guys have enjoyed it. If you get it, then give me the thumbs up or just reply in the chat box. So, okay, Bhargava, Lakshmi, Prashant, Payal Chauhan, and Jamie Bhavnagar. Have you all got this? Have any kind of doubt you have? Just write it in the chat box so that I'll get you do not have any kind of doubt in this. Okay? And you are listening to me. The very important thing also. Yeah, Lakshmi, thank you so much. Thank you so much for the attending the session. Thank you so much you all for attending the session. Okay, I hope you are clear with this, what I have taught you. Just keep practicing more and more question and variety of question. Okay, only Lakshmi is responding, na? No one else. Okay, got it. You are not interested in responding. No problem. Okay, so I've just now stopped sharing my screen, and also, okay.